My name is Logi and my metric number is CF210242. The Laplace transform is widely used integral transform in mathematics with many applications in science and engineering. The Laplace transform can be interpreted as a transformation from the time domain where input and output are function of time to the frequency domain where input and output are function of complex angular frequency. Laplace transform method have a key role to play in the modern approach to the analysis and design of engineering systems. The concept of Laplace transform are applied in the area of science and technology such as electric circuit analysis, communication engineer, control engineer, and nuclear physics, and so on. Structures such as building and bridge consist of a number of components such as beam, column, and foundation, all of which add together to ensure that the loading that the structure carries is safely transmitted to the supporting ground below. Normally, the horizontal beam can be made from steel, timber, or reinforced concrete and have a cross-sectional shape that can be rectangular, T or I shape. The design of such beam can be complex but is essentially intended to ensure that the beam can safely carry the load it is intended to support. This will include its on-cell weight, the weight of structure it is supporting, and what is often referred to as live load. As a graduate engineer working in a structural engineer's office, you have been given the task of assessing the maximum deflection that will occur in the steel beam of steel frame structure and ensuring that they are not excessive. In this example, you will apply standard deflection formula to solve some typical beam deflection design problem. This formula from the basic of the calculation that would be undertaken in real life for many routine design situations.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sabrina binti Sazali and my metric number is CF210209. So for this video, I'm going to explain to all of you about problem statement. For short briefing, in our project, we are using Laplace transform for determining the deflection of the beam. For the problem statement, there are three we include in our project. First, we are going to determine the response or behavior of structure loads with some specific combinations of loads. Second, response includes support reaction, internal stresses, deformations, and displacement. And number three, we also include vibrations, stability of component systems, and occurrence of damage or failure.
Hi, I'm Darshan Rao from section 9, group 1. Okay, today I'm going to present about our project in engineering mathematics. Okay, our topic is about application Laplace transform in civil engineering. Okay, today I'm going to present is about objective study. Okay, the first objective study I'm going to present is the development of a systematic procedure of analysis using the Laplace transform as applied to elementary beam, symbolized and terminology compatible with background in the system engineering. Okay, the second objective is about the development of general solution to elementary beams that are subjected to any transfer system of a distributed load, concentrated load, and apply moment. Okay, the last, which is a third objective study, is the uses of Laplace theorem method as a basic tool analysis in this impact investigation. Okay, these are the objectives we are going to do in our project. Okay, all right, thank you. That's all from me.
Hi, Assalamualaikum. I am Nur Nadia Izzati binti Zamri, CF210212, and I will present to you about solution in this project. Okay, so we are going to continue to the next slide. Okay, so we choose Laplace transform in order to make the calculation for application in civil engineering. So this is the solution for Laplace transform. Okay, so here you can see and then we will get the y-x at the end of this question. Okay, the next slide. Okay, so the first question we will be solve using Laplace transform, and then we will be continue to solve the B, C and D question using deflection curve and find the final solution. So I will Okay, so this is the question C, which is we will find equation of deflection curve. Okay, so we go to the next question. And for the question D, we will be find maximum deflection that will occur when map becomes 0 in between the space. So for the conclusion, this Laplace transform can be the first step, okay, to solve solution until we get the final solution using different equation and also different calculation. That's all from me. I will pass this presentation to the next presenter.
For discussion, solution for question A, using Laplace transform to find y-x in terms of C1 and C2. Differential equation become polynomials of S when converted into Laplace domain. Solution for question B. Differentiating the deflection equation twice, we get the constant by the last two boundary conditions at x equals to L by solving equation 1 and 2 to get C1 and C2. For solution for question C, with C1 and C2, we get the final equation of the deflection formula for the beam subject to the point load by substituting C1 and C2 into the previous equation. From differentiating the final equation of the deflection of curve, we get the equation of the slope. For solution question D, the maximum deflection will occur when slope becomes 0 in between the span. Therefore, assuming the maximum deflection point at distance x is more or equal to L over 2, hence solving the maximum deflection of the beam. In conclusion, this Laplace transform is invertible on the huge class of function. The reverse Laplace transform makes use of the complex varying S and yield the function of the series variable t, given the example numerical or practical form of the input or output to the method. The Laplace transform offers an alternate useful form that frequently simplifies the process of examining the behavior of the system in synthesizing the new structure from the set of significations. Thus, for instance, Laplace shift from this period region to the frequency region transforms differential equations into algebraic equations and convolution into multiplication. And it has numerous applications in this science and engineering. That is for our group. Thank you.